Hello students, welcome back to Organic Embers. Many of you have requested me to solve advanced level NEET questions. So I have picked some questions from the basic concepts of organic chemistry in order to understand the concept in detail. So let's get started. The first question is based on aromaticity. You have to identify the aromatic compounds from the given 12 compounds which are mostly heterocyclic in nature with either nitrogen, oxygen or sulfur. You might wonder how to do this in 1 or 2 minutes, but don't worry, I'm going to give you a simple trick here by making use of the options given. You see in option A and C, from 1 to 6, it is common. What about in B and D? 1 to 3, it is common. That means what? The first three compounds are aromatic in nature by default. How they are aromatic? Because they are cyclic and they are planar and there is a continuous conjugation and they are obeying Huckels 4n plus 2 pi electron rule. For heterocyclic compounds, it's a little bit tricky to identify whether they will obey Huckels 4n plus 2 pi electron rule or not. I'll explain for the first molecule. It is applicable for rest of the heterocyclic compounds. On the nitrogen, there is a lone pair and this nitrogen is sp3 hybridized. That means what? This lone pair is available for the resonance. Usually, sp3 hybridized nitrogens are pyramidal in shape. Because it is undergoing resonance, it will become planar. Since it is undergoing resonance, it is in conjugation. Because it is in conjugation, it is obeying Huckels 4n plus 2 pi electron rule where there are 6 pi electrons. So the lone pair is also considered as a pi electron in this case. Then when you solve for n value, you are going to get 1. That means what? It is aromatic in nature. For second compound, however, there are two nitrogens. You can ask me, ma'am, there are two lone pair, right? So it will not obey 4n plus 2 electron rule. No, you should not take this nitrogen for the resonance. Why so? Because this is sp3 hybridized, so pyramidal, it can change to planar. But this one, it's already in the plane and it is in perpendicular to the pi electron cloud present here. If it is perpendicular, how can it go in the plane as this electron system? Not possible. So you should not take this, right? So then what happens? 2, 4, 6. That means it is obeying Huckels rule. Same here for the third molecule. Here again there are two lone pair, but one will be in perpendicular, the other one will be in parallel. So you should take only one lone pair out of two lone pairs. So aromatic. Same with the thiophene. Because oxygen, sulfur, they are from the same group, right? So behavior will also be same. So again, this is also aromatic. Here we have oxygen and nitrogen, but this nitrogen will be perpendicular. The lone pair present on oxygen will be in resonance like this, right? So you can see that from compound 1 to 6, all of them are aromatic in nature. Students, however, compound 4 and 6, they have given it same. There might be some typo or some error. You can ignore that part. You can see here in option A and C, from 1 to 6, all of them are same. So answer has to be either A or C. And you can eliminate B and D. If you just decide for compound 7 and 8, you can easily answer this because again here it is common, right? So let's check for these two compounds. Although there are two nitrogen, in both the cases, the lone pair will be in perpendicular. So this is similar to benzene, isn't it? So this is also aromatic in nature. What about here? The lone pair will be involved here. So it will not obey aromatic rules. It will obey anti-aromatic rules. This is not correct. Compound 7 is aromatic. Hence, the correct option is option C. The next question is based on the number of enolizable protons. You have to arrange the given compounds in the decreasing order of their number of enolizable protons. First, what do you mean by enolizable protons? The hydrogens which are involved in enolization process. Enolization also can be called as tautomerization or tautomerism. So here what you have to do is identify the number of alpha hydrogens. Alpha hydrogens are the one which will be involved in the enolization. What do you mean by alpha hydrogens? The one which are attached to alpha carbon. Alpha carbon is the one which is attached to the functional group. So here this is the carbon which is attached to the functional group. And what about here? This is attached to the functional group. This cannot be alpha carbon because this is an ester. Ester carbon is over here and the carbon attached to the functional group carbon is called as alpha carbon. This cannot be alpha carbon. This is very important. So please do remember. This is ketone. This is a carbon. Since the carbon is attached to the carbon on both the sides, we have two alpha carbons here. Count the number of alpha hydrogens here. We have 3 alpha hydrogen. Those are the enolizable hydrogens. What about here? Only 2. What about the third compound? 2 plus 2, 4 alpha hydrogens. Which compound is having more number of alpha hydrogens? The third compound. Hence, the right option is option D. Students, I would like to explain what is enolization quickly here. So, whenever you have compounds like aldehydes, ketones, esters, amides, nitro compounds, all these can undergo enolization. Why so? Because of this oxygen. Oxygen is a electronegative element. So what it does is it will withdraw the pi electrons present here. Because of these, the hydrogen will give the sigma electrons to the carbon. So then what happens? It's going to form enol like this. There is a carbon-carbon double bond, ene, and alcohol all. So that's why we call this as enolization. And it will be always in dynamic equilibrium with each other. Depending on the number of alpha hydrogens. 3 hydrogen means all of them will undergo enolization. So based on the number of these alpha hydrogens, you can predict the number of enolizable protons. The next question is based on the formal charges. You might have learned this in chemical bonding chapter. There is a Lewis dot structure for a diazo compound. You have to find out the formal charge for the carbon and the nitrogen which is attached to that carbon. There are 2 ways of doing this. One is directly using the formal charge formula, that is formal charge is equal to number of valence electrons minus number of non-bonding electrons, that is lone pair of electrons, minus half of the bonding electrons. But this is time consuming. The best way to do is to find out the valency of the atoms and the lone pair on these atoms. What I mean is whenever carbon is tetravalent, right, it will not have any lone pair on it, then the formal charge would be 0. If the valency is 3 and it is having lone pair of electron, then the formal charge would be -1. If it is trivalent and no lone pair, then the formal charge will be +1. Pretty easy to remember. Let's do for nitrogen now. Nitrogen is trivalent, then the formal charge would be 0. If the nitrogen is tetravalent, so it cannot have lone pair on it, then the formal charge will be +1. If the nitrogen is divalent, it will have 2 lone pair. In that case, what happens? The formal charge will be -1. From this, what you know here is the carbon is -1. Where do we have it? Either B or C. And nitrogen here will be +1. And which is the correct option in that case? Option C. Students, I would like to give little extra information about the molecule given here because this is a special case wherein we generate carbene as a reaction intermediate. Whenever nitrogen is tetravalent, it cannot withstand this charge. What it does is it will take away the bonding electrons and it will escape as a nitrogen gas. Then what happens to this carbon? This carbon is divalent with lone pair of electrons. And what do you call this as? We call this as carbene. Carbene is a reaction intermediate formed during the course of the reaction and they are highly reactive species. The fourth question is based on the nucleophilicity of the given nucleophiles in polar protic solvents. Nucleophiles are the electron-rich species which can donate the lone pair to the electron deficient centers. How easily it donates the lone pair to the electrophilic carbon decides its nucleophilicity. If it is more electron rich, if it gives electrons easily, then we consider it as a better nucleophile. The given three species are nucleophiles because of the lone pair of electrons present on oxygen, sulfur and nitrogen respectively. In methanol, the oxygen will give the lone pair of electrons. In thiol because sulfur is present in the alcohol, right? So thiol, the sulfur will donate the lone pair. In methanamine, nitrogen is the nucleophilic center. Now, when all these compounds are taken in polar protic solvents, so what are polar protic solvents? Like water, right? Methanol, ethanol, carboxylic acids, right? All these are considered as polar protic solvents because they can furnish protons. Will they affect in the nucleophilicity of the compounds? Yes, that is what we are discussing here. Whenever there are nucleophiles like this, right, like in case of methanol, oxygen is the nucleophilic center. The lone pair of electron of this oxygen will interact with the hydrogen of the solvent. And what do you call this as? We call this as hydrogen bonding because the hydrogen of the water, which is electron deficient, will start interacting with the lone pair of electron present on the oxygen. So all the water molecules, whatever is surrounding this, right, it will form a kind of cage-like structure like this. Because of this, what happens? Its nucleophilicity is somewhat decreased. Will it be same for all the atoms here? No. It depends on the size of the atoms present here. The polar protic solvent decreases nucleophilicity by tightly caging and stabilizing nucleophiles through hydrogen bonding. Because of this, the nucleophile, right, it must shed the solvent shell to attack the electrophile. Smaller the size of this atom, it is deactivated most because of this hydrogen bonding. So among the three atoms, whose size is greater? Sulfur size is greater. So not much cage-like structure. So it can attack easily. So where do we have 2 as the highest? There is only one such option. So straight away go ahead with option B. So thiol is considered as a better nucleophile. Then what do we have? We have methanamine. Again, oxygen size is smaller because it is more electronegative element as compared to nitrogen. So it will get better stabilized by this protic solvent. Therefore, it will be the least. The last question is based on the resonance phenomena. There are 5 pairs of compounds given which are undergoing resonance. Whether these resonating structures are right or wrong, you have to choose from the correct options. The first molecule is alpha beta unsaturated ether. That means what? This lone pair is in resonance with this pi electrons. So when the lone pair moves here, depending on the arrows used, you have to get the correct structure. So when it moves here, the double bond is formed. Since oxygen is trivalent, it will have positive charge, and the lone pair is moving to this carbon means negative charge. So this is correct structure. And where do we have 1? In option A, B and D. So eliminate option C. Now let's verify for the second molecule. This is formaldehyde. So when you have formaldehyde, you see there is no resonance possible here. There is no alpha beta unsaturation. So even if this lone pair is given to the carbon here, the carbon will become pentavalent, which is not possible at all. So 2 is not exhibiting any resonating structure. So if there is 2, eliminate that option. So this is not possible. So it has to be either B or D. So let's verify for the third one. See, in resonance, only the pi electrons and lone pair electrons will be delocalized, not the atoms. But in structure 3, you see the hydrogen is delocalized. Is this possible? Not possible at all. Therefore, eliminate option 3. This also should be eliminated. So what is the correct answer we have? Option B. Directly go ahead with B and you don't even have to verify for 4 and 5. However, I'm going to explain for molecule 4 and 5. So is this resonance correct? Yes. How so? Look at this. When the lone pair of electron present on nitrogen move to carbon, the oxygen will take away the electron. So the delocalization of lone pair and pi electron is happening to give the correct structure. Why is this wrong? Because it is not alpha beta unsaturation. Here it is beta gamma. Beta gamma means what? It is far away from the lone pair here. So it cannot undergo resonance. So this is also wrong. Students, I have included some questions at the end of this video. You have to solve those questions because I always believe in active learning but not the passive learning. So if you have any doubts, you can comment your queries in the comment section. I will always help you with that. And don't forget to subscribe the channel. Thank you.